In this video we will be going over quadratic functions. So a quadratic function is a function that is in this form: f of x equals ax squared plus bx plus c. We call this the general form of a quadratic function. Now the important thing to note about a quadratic function is we have the variable, which is x, getting squared. So anytime we have our variable, or the input variable, in this case x, if the highest exponent of that variable is 2, we have a quadratic function. Now, a second way that we can write a quadratic function is called standard form. And standard form looks like this: f of x is equal to a times x minus h squared plus k. We call this standard form. Sometimes people call this vertex form. So standard form or vertex form. And the reason this is called vertex form is because in this form we say hk is the vertex of the graph. And we'll talk more about the vertex here when we start graphing some of these functions. Now, to get to standard form, we can start out with the parent function, and the parent function is just going to be f of x is equal to x squared. And then let's apply a few different transformations. If we shift this to the right h units, we would have x minus h squared, so that would be right h units. If we were to shift this up, well, let's shift up in a sec. Let's apply vertical stretch. So if we multiply by a factor of a, this would be a vertical stretch or compression by a factor of a. And then lastly, if we shift this up k units, we would add a k to the end of the function. And that is how we can get to this standard form here. Here's an example for us. Write the standard form of the quadratic function with a vertex of -3, 4, and passing through the point -4, 7. Now, what this means is we're going to write our function in standard form. So standard form is a times x minus h squared plus k, and h and k are the coordinates of the vertex. So we're given a vertex, -3, 4, so we can go ahead and input these values. So x minus -3 squared plus 4, and that's equal to f of x. So just cleaning, I'm not going to rewrite it, but if I clean up these two negatives and make that a positive, we will have this. Alright, so what we need to do is we need to find the a value here. And what we do is we use the second point, -4, 7, plug that in for x and f of x, and then we can solve for a. So 7 is going to be f of x, so 7 is equal to a times x is -4 squared plus 4, and then we just solve for a. So 7 is equal to a, -1 squared plus 4. Subtract the 4 and square the -1, we get 3 equals a times 1, so a is just equal to 3. So what we have here is we have the a value, and then we have h and k. So putting this all together, we're going to have f of x is equal to 3 times x minus -4, or sorry, 3 minus -3, so x plus 3 squared plus 4. So that is our function in standard form. Next, we want to be able to graph a quadratic function. So these are the steps that we can follow to graph quadratic. We can first find the vertex, determine whether the parabola opens up or down, find the x and y intercept, and then determine the axis of symmetry. So let's talk about each of these items here, and we'll do that with just a parabola that I just drew. So the vertex, what the vertex is that is this point down here, and if we are in standard form, the vertex is HK. That's one way. So if we're in standard form, HK is the vertex. So that's standard form. If we're in general form, well, general form looks like this. F of x is equal to ax squared plus bx plus c. So to find the vertex in general form, I'll just write GF for general form. What we want to do is we say negative b over 2a, that's the x-coordinate of the vertex, and then what we do is we take that x-coordinate and we plug it into the function. So we say f of negative b over 2a. So that gets us the vertex. So depending on which form we're in, that'll tell us how we can find the vertex. Alright, determine which way the parabola opens. Now, this parabola is opening up, so this one opens up. The parabola could also be opening downward. And this is all based on whatever the a value is. So if a is positive, we say the parabola opens up. If a is negative, we say the parabola opens down. Okay, so if the leading coefficient is positive, we're opening up. Negative will open down. I'm going to find the x-intercept, and there could actually be, I should say, x-intercepts. And a parabola could have 0 intercepts, it could have 1 x-intercept, or it could have 2 x-intercepts. This parabola that I drew, has 2 x-intercepts right here and here. So what we want to do to find the x-intercept, we solve, or rather, we find out when f of x is equal to 0. So in other words, we say 0 equals ax squared plus bx plus c. So we need to solve that equation, and we'll see how to do that here when we look at an example. So again, there could be 2 x-intercepts. If we have a parabola that is opening down like this and never hits the x-axis, that would be an example when we have no x-intercepts. We could also have 1 x-intercept if the parabola just comes down and touches the x-axis. Alright, next, find the y-intercept. So to find the y-intercept, what we do is we input 0 into the function. So f of 0 tells us the x-intercept, f of 0 tells us the y-intercept. Now, every parabola will only have one y-intercept. One and only one y-intercept. There's never 0 y-intercepts. So if you look at this parabola right here, now how I've drawn it, it doesn't look like it hits, or doesn't look like it yet hits the y-intercept, or the y-axis. But if it keeps going, eventually it's going to hit that y-axis. So there will always be one and only one y-intercept. Alright, lastly we need to find the axis of symmetry. So the axis of symmetry is, let's go back to this green parabola. The axis of symmetry is this imaginary line that cuts the parabola right in half. It's a vertical line, and it goes through the vertex. Now if you look at the coordinates of the vertex, well, h is the x-coordinate, k is the y-coordinate. So the axis of symmetry always goes through the x-coordinate of the vertex. And a vertical line is always of the form x equals some value. So the axis of symmetry is always going to be an equation like in this form, x equals h. Now it's useful to know, or to find the axis of symmetry, because if we pick a point on this green parabola, let's pick this point, this distance right here, let's call that, how about we call that distance m? So that distance from the axis of symmetry rightward to the parabola is going to be the exact same distance if we look here on the left side. Okay, so that axis of symmetry cuts the parabola in half. So this is useful because if we know the coordinates of, let's call these M1 and M2, if we know the coordinates of M1, or the point M1, if we know the coordinates there, well, we can find the distance from the axis of symmetry, and once we know that distance, we can look at the distance leftward, and that'll give us this point over here. Let's check out this example. Convert f of x equals x squared minus 4x plus 3 into standard form. Find the vertex, x and y intercepts, axis of symmetry, and graph. So the first thing we'll do is we'll convert this into standard form. Now remember, standard form, also sometimes called vertex form, looks like this: a times x minus h plus k, where h and k are, or h comma k is the vertex. Now there are two ways we can do this. One is probably the way most books show you to do it. The second way is kind of a cheat, I would say. It's not probably what most teachers would show you to do, but it works, and it's just as valid. So the first way is by completing the square, which is a good skill to have, and we use that often, especially when we're working with conics. We can also solve quadratic equations by completing the square. So how this works is f of x, we take the function x squared minus 4x, I'm going to leave a space, and then I'll write plus 3. Now what we want to do is we want to take this quadratic and write it into a perfectly factored form. And looking back at the standard form, we forgot to square right there. Okay, so what we do is we look at the b value right here, and the b value is negative 4. And what we do is we take half of the b value, and then we square that. Okay, so the b value here is negative 4, so we're going to take 1/2 of negative 4, and then we're going to square that. So half of negative 4 is negative 2, negative 2 squared is 4. So what we do is we add 4 here. Now, if I have a function, I can't just decide to add 4 wherever I want. Now, if I add 4 in this position, I also need to subtract 4 here. So by adding 4 and subtracting 4, I haven't changed the value of the function. Now, the whole reason we do that is looking at these first 3 terms, I can factor this, and this factors as two binomials that are the exact same, x minus 2 and x minus 2. And what we can do is we can write this as x minus 2 squared. And that looks a lot like the form that we have, x minus h squared in the standard form. So we just need to finish this up. 3 minus 4 is going to be negative 1. And the a value, it's a 1 there. We don't have to explicitly write it, but I'll just write it for the sake of clarity here. So what we have now is this this function written in standard form. And once we're in standard form, it's really easy to find the vertex. So what we'd say is the vertex here is h comma k, so that's going to be positive 2 comma negative 1, and that's the vertex. Okay, now the second way, and probably the frowned upon way to find the function in standard form, is to first determine the vertex. Now, when we're in general form like this, the vertex is negative b over 2a, and then we plug in that value, negative b over 2a, into the function. So negative b, so b is negative 4, so opposite of negative 4 divided by 2, the a value is 1, and that gets us 4 over 2, which is 2. And then we input 2 into the function, so f of 2 is going to equal 2 squared minus 4 times 2 plus 3, we get 4 minus 8 plus 3. It's going to be negative 4 plus 3 is negative 1. So the vertex here is 2 comma negative 1. Now if we remember, the standard form is f of x equals a x minus h squared plus k. Now the h value is just the 2, the k value is negative 1. So what we could do is we could say f of x is equal to x minus 2 squared and then minus 1. And now for the a value, well, the a value comes from what we had originally, whatever the coefficient on x squared is. And the coefficient on x squared is just positive 1, so this is going to be a 1 here. And again, this is a perfectly legitimate way to write this in standard form. So either method will work. So back to the previous slide, we have the function in standard form. We have the vertex. We need to find the x-intercept. So to find the x-intercept, what we do is we take the function x squared minus 4x plus 3, and we set that equal to 0. We solve this. We can solve this by factoring x minus 3, x minus 1, and then using the zero product property. X minus 3 is 0, so x is going to equal 3. X minus 1 is 0, so x is equal to 1. And it's important that we write on any of our intercepts as ordered pairs, because the intercept is a point. So 3 comma 0 and 1 comma 0. Those are the values of the x-intercept. And then for the y-intercept, what we do is we take the function and we input 0 into the function. So f of 0 is going to equal 0 squared minus 4 times 0 plus 3. So f of 0 is equal to 3. So the coordinates of the y-intercept, we're going to say, are 0 comma 3. And then lastly, we need to find the axis of symmetry. And remember, the axis of symmetry is just a vertical line that is cutting through the vertex. And the vertex is 2, negative 1. So a vertical line through that point is just going to cut through or go through the x coordinate here. So we're going to say x is equal to 2 is the axis of symmetry. At this point, we have a lot of information. We have the y-intercept, we have 2 values for the x-intercept, we have the vertex, and the axis of symmetry. Kind of putting all of this together will allow us to look at or come up with a graph of this function. Alright, so let's start with the vertex. The vertex is positive 2, negative 1. So vertex is something like right here. Because the leading coefficient is positive, this parabola is going to open upward. The x-intercepts, we have 3 comma 0, and then we have 1 comma 0. So we have a couple points there. Then we have the y-intercept of 0 comma 3. So we're going to cross right there. And then we know that the axis of symmetry cuts right down the middle. Alright, so using this axis of symmetry, we can say that, well, this point right here, or that distance, is 2. So what that means is the distance to the right is also 2. So that point right here, well, the coordinate of the coordinates of the y-intercept, we have 0 comma 3. So what that means is the point to the right of the axis of symmetry, the y-coordinate is still 3, but the x-coordinate is going to change. And if we know that that axis of symmetry is at 2 along the x-axis, if I add 2, that gets us to 4 comma 3. So it's helpful, it's useful to find a few more points than just the vertex and the intercept. So there's 1 point, 4, 3. And then to graph this, we can just make a smooth curve like that. For this example, we need to convert g of x equals 5x squared minus 20x plus 8 into standard form. Also find the vertex, x and y intercepts, axis of symmetry, and graph. Now I'm not going to go through all of this in the video, but I will get it started. First of all, let's complete the square here. 5x squared minus 20x plus 8, and I want to do this because this is slightly different because of the a value that is not 1. We have an a value of 5. Now to complete the square, we want to factor out from the first two terms the 5. So it's 5x squared minus 4x. I'm going to leave a space, and then on the back end I'm going to put plus 5. Now this is the inside part here is pretty much is exactly the same as the previous example where we completed the square. So take half of negative 4, which is negative 2, and then square that, which is positive 4. So we're going to put a plus 4 here. Now, by putting a plus 4, I haven't just added 4 to the value of the function. What we've done is we've actually added 4 times 5, which is 20 to the value of the function. Because if we were going to multiply this out, we would get 5x squared minus 20x plus 20. So we've actually added 20 to the value of the function. So what we need to do is subtract 20 outside. And that allows us to complete the square. This inside part factors to x minus 2, which is x minus 2 squared, and then negative 20 plus 8 is negative 12. So that gets us the function into standard form. We could have also done the negative b over 2a and then plug that value into the function to find the vertex, and then we could have used this 5 as our a value, which just comes down right here. Alright, from there we follow the exact same procedure to find the x and y intercepts, the axis of symmetry, and then the graph. My suggestion would be to pause the video right here, see if you can find those things, and then hit play, and you'll be able to check your answers. So finishing everything off, we have a vertex of 2, negative 12, x-intercept of 10 plus or minus 2 root 15 over 5, comma 0. So one x-intercept will be 10 plus 2 root 15, one will be 10 minus 2 root 15, and you need to use the quadratic formula to get these values. So you got to use the quadratic formula here. Okay, and the reason is because when we set 5x squared minus 20x plus 8 equal to 0, that does not factor, so we need to use the quadratic formula to solve that. We get a y-intercept of 0, 8, and then an axis of symmetry of x equals 2. And then we have the vertex, we have both x-intercepts here. Here we have the y-intercept, and then using the axis of symmetry, we know that the distance here is 2, so this distance here is also 2. Alright, we'll look at two more examples here in this video. The first one is to solve this inequality by graphing write the solution in interval notation. Now what this means is, let's just talk in generalities here. Suppose we have a parabola, and the parabola is opening downward. We have something like this. Now, looking at this parabola, well, what we would say is that in between these x-intercepts, the parabola is above the x-axis. So we would say in that interval, the parabola is positive. And then what we would say is everything to the right of this is going to be negative, and everything to the left over here would be negative as well. So if we had an inequality, a quadratic inequality here, and it was asking us where is this function negative, what we would do is we would give this interval and we'd give this interval. If it asked us to say where the quadratic was positive, well, we would give this interval in here. Okay, so let's go back to our specific example, and thinking back to this the general case over here, what we need to do is figure out what the x-intercepts are. Now, to find the x-intercepts, we take the quadratic, we're going to set that equal to 0. Now to solve this, let's try and solve by factoring. And I believe this factors to, let's see, negative 8 and 5, is that right? Negative 24 plus 5 is negative 19, yeah. So that's how it factors. So let's solve for x. 3x plus 5 equals 0, so x is going to be negative 5/3 here. And then x negative 8, x minus 8 is 0, so x is going to equal 8. So what this means is these are the x-intercepts of the parabola. And we don't have to be 100% precise here. So the x-intercepts are at these locations. And we know the parabola is opening upward because the leading coefficient is positive. So this parabola is going to go through these positions on the x-axis. It's going to look something like that. Now, because the inequality says greater than 0, that's another way of saying positive. So we want to know, where is this quadratic positive? Well, this quadratic is going to be positive in this interval over here. It's positive there because that's where the graph is above the x-axis, and we're positive over here. So writing this in interval notation, well, we're going to say negative infinity up to negative 5/3. And we don't want to include negative 5/3 because negative 5/3 at that value, the parabola is actually on the x-axis, so it's not positive nor negative. It's equal to 0. So we don't include the endpoint there. And then union, starting again at 8 up to infinity. So this would be the interval where the parabola is positive. If this inequality was less than 0, if this inequality was less than 0, we would want to know where this is negative, and this parabola is negative in between those two x-intercepts. This one asks us to find the signs of A, B, and C given the graph, and determine if any of A, B, or C are 0. So we need to determine whether A, B, or C are positive or negative. Well, first thing to notice is that this parabola is opening downward. So because this is opening downward, the leading coefficient, A, must be negative. So A is going to be negative. And then this y-intercept gives us some information. Now, remember, if we have a function that is quadratic, to find the y-intercept, what we do is we input 0 into the function. And if we input 0 into the function, we're going to get ax squared equal to 0. We're going to get bx also equal to 0. And then we're just going to get c. So f of 0 is always equal to the c value. So c corresponds to the y-intercept. Here, the y-intercept on this graph is positive, so the c value must be positive. Now, the b value is a little bit harder to determine here. Now, the b value comes into play when we are finding the vertex, because the vertex can be written as negative b over 2a, comma f of negative b over 2a. And what we know about the vertex, well, the vertex corresponds to this hk point here. What we know is that the h value is negative, because that's just the x-coordinate of the vertex, and since we're in the third quadrant, x is negative, and then k is positive. So what we know here is that this negative b over 2a, this must be negative, and then the y-coordinate must be positive. Well, if we take negative b over 2a, and we know that that's a negative number, well, we need to solve this for b, because we need to determine the sign of b here. So multiply both sides by 2a. We're going to get 2a times some negative number. And then to solve for b, we're going to divide by a negative. So divide by a negative. And what we get here is, well, we get a b value that is equal to Well, on the right side, the negatives cancel and we get a positive 2a. That tells us that we have b equal to 2a. Now we know that a is negative. So what this means is that b is equal to 2 times some negative number. 2 times a negative is going to be negative. So we know that the value of b is negative here. And the last example tells us that a revenue function is given by r of x equals 15 plus 114x minus 3x squared, where x is the number of units produced and sold. Find the value of x for which revenue is maximum. So we want to take this function, this revenue function, and we want to know for what input, x, is this going to be maximum? Well, this is a quadratic function, and I don't know exactly what this looks like, but what I do know without doing any work is that this is going to open downward. And that's because the leading coefficient, while this isn't written in descending order, it's not written how we usually see it, the leading coefficient is -3 there. And because that's negative, the parabola opens downward. Now the maximum value is going to be right up here, and we call that the vertex. So if we can figure out what the vertex is, we'll be able to answer this question. So r of x is equal to -3x squared plus 114x plus 15. Now, I could put this into standard form. This is going to be kind of a pain because we have a leading coefficient here. So let's just go ahead and find the vertex right away. So negative b over 2a. It's going to be -114 over 2 times -3. We get -114 divided by -6. 6 goes in there 19 times. So the x-coordinate here is 19. And we could solve for, or we could figure out what the revenue is when 19 units are produced and sold, but the question doesn't actually ask us to find r of 19. It just asks us to find the value of x for which revenue is maximum. And that value is going to be 19 units here. Now, you may be thinking that this doesn't totally make sense because most of the time when a company, or it would seem that if a company, the more units they produce and sell, that revenue is just going to continue to increase. That's kind of what we would expect. However, for this particular model, perhaps something like if more units are produced and sold, perhaps the company has to hire more workers, or they need to move into a bigger building. So there may be other expenses that occur when more units are produced and sold. So it's a good idea to know where that maximum value is if you're trying to maximize revenue.